Welcome to SW. My name is Eileen Fries.
My name is Marius Lehman. I work in technical sales and I'm also responsible for the machining of scroll compressors.
And I'm here today to interview Marius and find out why our SW machines are a good solution for scroll compressors. Marius, can you briefly explain what a scroll compressor even is? What it is used for?
Nowadays, scroll compressors are mainly used in electric vehicles. They're needed for faster car battery operation and to keep the battery from overheating during charging.
And what about the spiral shape? Why does it look like this?
The spiral shape, together with the housing and the orbital part, ensure that the air is being increasingly compressed by an eccentric rotating movement towards the center.
Okay, and is this something that SW has just begun doing, or do we have a bit of experience with it?
So, the scroll compressor has been around for a long time. It was first patented back in 1905. In 1987, SW delivered their first machines for the production of the Volkswagen G-Lauder supercharger.
A long time ago.
Yeah, a long time ago. Then, since 2016, we've had a machine available, the machine behind me, just for machining tests and quality verification for our customers.
So, SW is really familiar with this topic. We're in a technology center, as you might hear a bit from the noise. When SW sets up a machine like this, hopefully someone is here working every day.
Yeah, SW develops the perfect process for our customers, and we also develop tools independently at SW. In our processes, we're constantly optimizing our cycle times and other elements. We're available for all your questions about scroll compressors.
What requirements does a machine have for the scroll compressor? We've oriented ourselves to it, but what's important for the scroll compressor so we get a good, precise workpiece out of it?
Yeah. Like you said, the workpiece is very precise. We often deal with a profile shape based off the complete spiral with less than 20 microns. So, for that, you need a machine that's very precise, dynamic, has a quick tool change time, and has a certain temperature stability.
Okay, so you said a machine that's fast? How fast are our machines? What are they especially good at?
The W02 has a linear motor drive on all axes. With our pickup magazine, tool change times or chip-to-chip time is less than 2 seconds. We have a timed warm-up in the machines. There are measuring probes to compensate for potential warm spots or to measure the workpiece directly in the machine. The quality of the circular shapes in the machine is less than 3 microns.
So what is our approach to clamping? With this precise workpiece, you probably don't want a lot of clamping positions. How does SW solve this?
In the pre-machining process, which can be done with our 4-spindle machines, the workpiece is first clamped so it can be machined most sides. The workpieces usually come to us as forged parts and first need to be freed from their casting skin to relieve stress. In this 4-spindle pre-machining, we machine a flute on the outside diameter of the workpiece and drill an indexing bore in the middle of the workpiece. These will be used for clamping and defining the workpiece in the final machining operation. During the final machining, we finish all the tight tolerances in one clamping position. We hold the outside of the workpiece and can ideally machine both sides with our 4th axis. This is how we machine all bearings and achieve the accuracy for the spiral shape.
I think you can see this pretty well right on the machine here. The table rotates, right? So you have to imagine that the fixture stays still and that there's an opening behind it where it'll be machined again. Is that right?
That's right. We can see it here. This is our machining fixture. The workpiece you see here can be machined on its top side. The 4th axis rotates 180 degrees so we can machine the bottom of the workpiece in relation to the top.
Are there any other requirements we have for the machine or for the process when machining the scroll compressor?
Yes, the dynamic machine also requires a fast spindle. We designed this machine here with an HSK A40 spindle with 25,000 RPM and 17 Newton meters.
And what about the tools? Do you need a lot? Do you need a few? How is it with the scroll compressor?
I would say you need about 20 tools, which means you have to change tools in the machine often.
And they all fit in the machine? Or do you have to change the tools manually in between?
Our tool magazine is modular, expandable, and is customized to meet the customer's requirements.
The scroll is a very precise workpiece, and temperature also plays a role here. How does that work? Do we monitor the temperature in the machine, or how is the machine adjusted during the machining process when it's getting warmer and warmer?
The machine can be warmed up from a cold state with a timed warm-up. We've integrated a measuring probe into the machining process, which is used strategically depending on the situation in the machining area and detects a certain point in the fixture. That way, we can kind of compensate for the increasing temperature in the machine, and this only has to be done at the beginning of the process. Later, when the machine is at temperature, we can maintain this dimensional tolerance without having to measure again.
Here at SW, we're not just machine manufacturers. We also have complete system solutions. I can think of two options right now. Marius, maybe you can tell us first what solutions would fit really well with the WO2.
Sure. Here, we have the possibility of expanding the WO2 with a loading module. We can even save 180 workpieces in a fully loaded workpiece magazine and achieve a runtime of about 6 hours.
That means that no one has to operate, touch, or do anything with the machine for 6 hours?
Exactly.
Okay, but will the machine send alarms if something comes up?
With the option of the IDS, the Industrial Data Services, the operator can constantly stay up to date and see what the current state of the machine is.
Good. What else is there? We talked about the loading module, but SW has a lot of options for automation solutions. What would be another option for the scroll compressor?
A second option, especially for high-volume productions, would be a portal solution. The machine would be attached to a small portal rail where the robot moves and loads the machines. For example, the robot might move a workpiece from a machine after pre-machining to a machine for final machining.
Okay, and that's good for high-volume productions because then we're not limited by time, right? Would you say so? Because with the integrated automation, we have the storage tower where the workpieces are stored. Then they have to be taken out and later loaded back in. But with the portal, as long as there are raw parts there, it runs, right?
Exactly. And I would go with the portal solution when I, for example, have a number of machines I need to operate. For smaller production numbers, I mean less than 150,000 parts per year, I would go with the loading module and just load the tool magazine from behind, either manually or with AGVs.
And of course, financially, it's a lower cost solution to use the integrated automation instead of a large portal. Marius, what would you say to customers who are already machining scroll compressors or are looking at new projects that involve scroll compressors? What's your suggestion?
Yeah, it doesn't matter if your production numbers are big or small. Just reach out to your contact at SW about the production of scroll compressors. For aluminum parts, we have the WO2. And if you have a scroll compressor made of cast iron, for example, we also have the right solution for you. Our BA322i.
Marius, thank you for the interview. I hope our viewers were able to get something out of it. Like Marius said, contact us with any questions, and we'd be happy to take a look at your project or workpiece that you're currently machining. And we'll see if we can be faster, better, or maybe more precise for your production.